If you, like most of us, spend your time under the sun, well, there's this whole other world out there, a dark world that, frankly, we're just not built for.
Hmm.
Our whole evolutionary path, it leaned into color, into detail, things for a bright day.
Right.
But the moment that sun goes down, something else wakes up. A whole different set of biological rules kicks in.
It's true. We tend to think of night as just emptiness,
Hmm.
the absence of light.
Mm-hmm.
But for nocturnal species, it's a completely full sensory world.
Okay.
And that's what we're diving into today, these incredible adaptations that let animals not just, get by in the dark, but actually own it.
Right, own the night. So our mission here is to really unpack how they do it. Their vision that maybe isn't like ours, their hearing, their sense of smell,
Mm-hmm.
or maybe it's chemical sensitivity.
Exactly. How they perceive a world we can barely even imagine, and crucially, why these traits evolved. We're talking deep history here.
Millions of years.
Hundreds of millions, potentially.
Wow. And you mentioned you had a kind of a mind-blowing fact to kick us off.
Oh yeah, get this. Your average house cat, its eye can gather something like 135 times more light than yours can.
135 times. Seriously.
Yep. Talk about a superpower hidden in plain sight. Or, well, hidden in the dark.
Okay, let's definitely dig into that. Let's start with vision, since it's what we rely on so heavily. For us, more light equals more info. But for them, it's different.
It's about efficiency, really. It's a trade-off. Most nocturnal mammals, they actually sacrifice color vision. They have fewer cones, those are the color receptors in the eye,
Okay.
and instead they pack their retinas with way more rods. Rods are the light receptors.
So better sensitivity, less color.
Exactly. Their night vision is essentially super sensitive black and white. It lets them work incredibly well in really minimal light, like just starlight sometimes.
Which explains why they need such fine control over the light coming in. Which brings us back to the cat, that 135 times figure. How does that work mechanically? Is there a downside to opening up the floodgates like that?
Well, the mechanism itself is pretty genius. It's that vertical pupil. Unlike our round ones, it can shrink down to a tiny, tiny slit during the day.
Right, I've seen that. Almost closed.
Yeah, much smaller than a round pupil can get.
Yeah.
That protects those super-sensitive rods from getting blasted by daylight. Then, at night, they open up into these big, perfect circles.
Letting in a light.
Letting in, 135 times more photons compared to when they're just slits. The trade-off isn't really mechanical damage. It's mostly about the information they lose. They lose that high-detail color information. They see movement incredibly well, but the world's palette is just muted for them.
That design is just elegant. Okay, speaking of getting the most out of light, what about that kind of spooky eye shine you see? Headlights hit an animal.
Ah, yes. The tapetum lucidum. You see it in loads of animals. Gators, big cats, even rabbits and deer.
Tapetum lucidum. Right.
It's basically a layer of reflective crystal sitting right behind the retina. So light goes through the retina once.
Wow.
If it doesn't get absorbed, it hits these crystals and bounces straight back through the retina again.
Giving the photoreceptors a second chance to catch it.
Exactly. It's like built-in night vision goggles, amplifying whatever little light there is.
So it's not ghost eyes, just efficient biology.
Pretty much
Yeah.
a natural light booster.
Right, that makes sense. But what about places where even that kind of souped-up vision isn't enough? Like deep in a forest or dense jungle. You can't see far.
Right. That's where other senses take over.
Yeah.
If you can't see the world, you need another way to map it. And that often means super hearing.
And this leads to some evolutionary battles.
Oh, absolutely. The classic example is bats versus insects. For ages, insects evolved to communicate using really, really high-pitched calls.
Why so high?
To find mates, mostly, but also crucially, to avoid being heard by most predators who simply couldn't pick up those frequencies.
Ah, a private channel?
Kind of, yeah. So the pressure was then on the predators, like bats, to basically crack that code, to hear higher and higher.
And boy, did they succeed. The difference is huge. I mean, humans, we top out around, 20 kilohertz?
Roughly, yeah. Maybe a bit higher when you're young.
Okay. Dogs get up to maybe 45 kilohertz, cats around 65 kilohertz. But some bats.
Some bats push that way, way up. We're talking 120 kilohertz,
Yeah.
even higher in some species.
That's phenomenal.
And that incredible high-frequency hearing, that's the foundation for echolocation.
Right, the sonar thing.
Exactly. They blast out these high-pitched calls, and then they listen intently to the echoes bouncing back, not just off bugs, but off everything, trees, rocks, even thousands of other bats in a cave.
So they're building a picture with sound.
A detailed, real-time 3D map of their surroundings. They're essentially using sound as radar.
Oh.
It makes relying purely on sight almost, well, pointless for navigation and hunting.
You said almost pointless, so their eyes aren't totally useless. I mean, if echolocation is so good, why keep the eyes at all? Is there still some function?
That's a really sharp question. Yeah, almost is the key word. While they navigate and hunt primarily by sound, their eyes do still have jobs, mostly detecting ambient light levels.
Okay, like telling day from night.
Exactly. It helps sync up their internal clocks, their circadian rhythms, tells them when it's safe to leave the roost. It's like an older system that's been sidelined for the main task. But evolution doesn't just throw things away unless they become a real burden.
Fascinating. Keeps the old tools around just in case. Okay, so we've got these complex mammals. Let's shift down a bit. Smaller scale. Insects. They're out at night too. Do they rely on sound or sight?
Often, neither is primary. For many insects, the night world is mapped mostly by chemoreception. Basically, smell or taste.
Smell.
Okay.
But they're not sniffing around like a dog, are they?
No, not really. They're not interested in, the whole landscape of smells. They use their antennae, which are packed with these chemoreceptors, to lock on to very specific chemical targets, signals that mean food or a mate.
So it's more like chemical radar, looking for one specific signature.
That's a good way to put it, yeah. For things like mosquitoes or bed bugs, that target is often the carbon dioxide, the CO2, we breathe out.
Ugh, that's how they find us.
Yep. For cockroaches, it might be the specific chemicals from rotting fruit. For certain flies or beetles, it's the smell of decay. It's super efficient. They just filter out all the background noise and hone in on that one vital signal.
And we've learned to use that simplicity against them, right? With repellents.
Exactly. We figured out they're hardwired to avoid certain complex chemicals, like DET. We disrupt that targeted seeking behavior.
Okay, moving back up the food chain. Finding food is one thing, but if you're a predator, hunting things that are trying very hard not to be found,
Yeah.
you need some serious stealth. And the barn owl comes to mind.
Oh, the barn owl is a masterpiece of nocturnal engineering. They're one of the few birds that really cracked the night hunting code, especially for things like mice hiding under leaves or snow.
Their hearing is legendary, right?
Absolutely key. It's not just good hearing, it's about pinpointing. They have asymmetrical ear openings. One ear is slightly higher than the other on their head.
Higher. Why?
It allows them to triangulate sound in 3 dimensions. By measuring the tiny, tiny differences in when a sound reaches each ear and how intense it is, they can pinpoint exactly where that mouse rustle came from. Up, down, left, right.
So they can see in 3D with sound. But locating the prey is only step one. They have to get there without making a sound themselves. How on earth do they fly silently? It seems to defy physics.
It really does feel like it. It's not just one trick. It's a whole suite of adaptations working together. Think of it in 3 parts, focused on the feathers.
Okay, part 1.
First, the leading edge of their main flight feathers isn't smooth. It has these little serrations, like a comb. This breaks up the airflow as it hits the wing, turning one big whoosh into lots of tiny, much quieter microturbulences.
Clever, part 2.
Second, the trailing edge of the feathers has this soft fringe. It helps to smooth out the air leaving the wing, reducing that fluttering or ripping sound you might otherwise get.
Okay, breaking it up on the way in, smoothing it on the way out. What's the third part?
The third layer is the texture of the feathers themselves, especially on the underside of the wings and even their legs. It's covered in this soft, downy material that actually absorbs sound.
Like acoustic dampening.
Exactly. It's biological stealth tech.
Yeah.
The prey literally has no warning. 0.
Mm-hmm.
Until the talons hit.
Just incredible. Now, not all nightlife is about eat or be eaten so silently. Some creatures use the darkness differently. As a stage, maybe?
Like fireflies?
Right. Fireflies use bioluminescence. They make their own light.
Huh.
It's a chemical reaction, happens in their lower abdomen. Their little insect butts light up.
Huh. The technical term.
Well, yeah. And males fly around flashing in very specific patterns, different patterns for different species. It's like a Morse code. A chemical light-based booty call, basically.
Booty call. Got it.
Yeah.
And the females? Females are usually waiting, maybe on a blade of grass, and they flash back the correct response if they like the signal. Confirms the species, signals she's receptive.
That flashing light, though, it didn't start out as a mating signal, did it? I remember reading something about that.
No, it's thought that the light originally evolved as a warning. Like, hey, predator, I taste really bad, or I'm toxic. Aposematism, but with light.
Ah, like bright colors on a poison dart frog.
Exactly. And then later on, evolution kind of repurposed that existing warning light for communication and mating. Evolution is pretty thrifty like that, loves to find new uses for old tools.
It really is. Okay, these adaptations are amazing, but connecting it all back, this isn't just about other animals, is it? This whole nocturnal thing. It's part of our story, too.
This is maybe the most profound part. If you go way, way back, maybe 200 million years ago, during the time of the dinosaurs, all mammals were nocturnal.
All of us. Our ancestors.
Yep. We were likely pushed into the shadows, into the night, by the dominant reptiles of the day, the synapsids who ruled the daylight hours. The night was our refuge.
So for millions and millions of years, we were the night crawlers. Wow. What did we keep from that time? What biological baggage are we still carrying?
Quite a lot, actually. Our really good hearing and sense of smell, even if we don't always pay attention to them now, our amazing sense of touch, think about ancestral whiskers, which almost all mammals still have in some form. That was critical for feeling your way around in the dark.
Makes sense.
And crucially, warm-bloodedness, endothermy. That likely evolved or was strongly selected for during this period. We needed things like fur, specialized brown fat tissue to generate heat just to stay active in the cool night air.
Right, keeping the engine running.
And even things you might not think of. Our eyes lack strong protection against UV light compared to many diurnal animals. Why would they need it if they were always hiding from the sun? Even our fingernails are thought to be remnants of what were once claws, probably used for digging burrows. It's all echoes from that long, dark chapter of our history.
That is stunning. We carry the night inside us. But fast forward to today. These creatures, our distant nocturnal cousins, they're facing a totally new pressure, one we created. Light pollution.
Yeah, this is a huge modern issue. We hear about it confusing sea turtle hatchlings trying to find the ocean, right? But it goes way beyond that. Is it actually changing how sophisticated mammals behave? The answer seems to be a definite yes. Artificial lights totally mess up the natural behaviors, the circadian rhythms, of animals like raccoons, coyotes, owls.
How so?
Well, it forces them to shift when they hunt, maybe making them less efficient, or it pushes them into brightly lit areas where they're more exposed, more vulnerable.
And it's not just changing behavior, it can be directly dangerous too, right?
Oh, absolutely. Those bright lights often act like fatal attractions. Moths fly into bug zappers or streetlights. Frogs gather under lights, becoming easy prey. Migrating birds get disoriented.
It draws them into human spaces.
Exactly, into places where they risk encounters with cars, buildings, people, or just becoming easy targets for predators who've learned to hunt near the lights. We are literally flooding the darkness that shaped their very survival.
Wow. Okay, so this deep dive, it's really highlighted the incredible ingenuity of life after dark. From those crystal mirrors in their eyes to silent feathers and sound-based radar, evolution just went all out. Function over form, dictated by the darkness.
It really did. It created some of the most specialized, most successful creatures on Earth. And thinking about our own origins, our own deep history, being entirely rooted in that darkness. It makes you pause, doesn't it?
Yeah.
If so many of our fundamental traits reflect that time, what does it mean that we, modern humans, are now actively, aggressively erasing the night across the globe?
That's a heavy thought.
Maybe, just maybe, understanding how much we owe to that darkness, understanding our own history, could help us figure out how to better coexist with, and maybe even support, the amazing night crawlers still out there.
So next time you look out into the dark, maybe don't just see emptiness. Think about the world the cat sees, all shades of gray but incredibly bright. Think about the 3D sound map the bat is navigating, or that owl gliding like a ghost overhead. There's a whole other world waking up when we go to sleep, running on biological superpowers we've only just started to really understand.